On the first problem here, we will have negative x minus 2 less than a negative 3, or negative x minus 1 greater than 4. You have two different inequalities. It's either one or the other that will create a solution area. One's going to go one direction, one's going to go the other, and your solution will fall into one of those two areas. Solve the one on the left-hand side first, this one. So negative x less than negative 3 plus 2. We move this to the right, change the sign. Negative 3 plus 2 is a negative 1. And we must now divide the negative 1 by the negative 1 on the left. When you divide by a negative, you change the inequality sign. And we will have x greater than 1. On the right side, negative x greater than 4 plus 1, the opposite of this. 4 plus 1 is 5. So you're going to divide 5 by negative 1. When you divide by a negative, flip the inequality sign, so x less than a negative 5. Here is your graph, which must be straight. Have a 0 on it, and include at least the two numbers that you are graphing. You have a positive 1, and then 1, 2, 3, 4, 5 to the left is negative 5. These are open dots. So on this one you have x less than a negative 5, so an open dot, and then to the left. For this one it's x greater than 1, so open dot and to the right. The solution is the area that is shaded in and does not include the negative 5 or the positive 1. So the solution here for this compound inequality is going to be either this area or this one. You have to solve the left-hand inequality first. So when we do that, we have 3x less than a negative 2 minus 1, opposite of this. 3x less than negative 3, divide the negative 3 by the positive 3 to get a negative 1. On the right, you have 3x greater than 6 minus 1, that's the opposite of this. 3x greater than 5, divide the 5 by 3 to come up with 1 2/3. So x greater than 1 2/3. Okay, we need a negative 1 and 1 2/3, so we really just need a 0, 1, 2 in this direction, and going back just a negative 1. For the negative 1, x is less than negative 1. So we go back that way with an open dot. And then on the right, x greater than 1 2/3. 1 2/3 would be approximately here. You need an open dot, and then to the right. The solution is under the shaded areas, but does not include negative 1 or 1 2/3. We'll answer questions after we check. Any questions about that problem? Yep.
On the line graphs, do you always go to the left and right, whether it's a negative or positive? Like how about the signs, like where it goes?
You go where it tells you to go.
How do I know where it goes?
Here's the x, and here's the number. There's negative 1. Inequality sign is pointing at the x. That means it's less than. Less than means you decrease, so you decrease as you go to the left on the number line in negative territory. The mouth opens towards the x, so that means it's greater than this number here. So it would have to go to the right if it's greater. Any other questions? Alright, seems like we have just enough time for one more. Won't go back. Well, I have to restart this for something happened there. There we go. Now we'll try again. Here is a bonus. On the left-hand side here, we need to keep negative x and move the minus 1 over to the right, make it plus 1. On the right-hand side, you'll have a negative 1. So now we divide the right-hand side negative 1 by the left-hand side negative 1 and flip the inequality sign to get x greater than 1. On the right-hand side, we'll have negative x greater than 3 plus 1, opposite of this. 3 plus 1 is 4. Divide the 4 by the negative 1. Flip the inequality sign. X less than a negative 4. So here is the number line. We need a 1 and a negative 4. So we'll put the 0 here. There's a 1, negative 1, negative 2, negative 3, negative 4. Open dot this way, open dot this way, and the shaded regions represent the solution to the inequality.